Welcome to lesson 10.3 for pre-calculus. Today we're going to go over another type of conic section called an ellipse. So as we go into this, let's go over some key terms first for an ellipse. So first, the definition. An ellipse is a set of all points x, y in a plane where the sum of whose distances from two distinct fixed points called foci is constant. So the way that I want you to think about what an ellipse is or how it's drawn is if you were to take a pencil and attach two strings that have the same exact length to them, to the pencil, and those two strings are at two different points. The figure that you're going to draw, keeping those strings tight as possible, that's going to be an ellipse. And where those strings are connected to the piece of paper or to whatever, those are called the focal points or the foci. Okay, so as you can see on this diagram, we've got a major axis and a minor axis, and we've got some focal points. So the major axis is going to be the longest line of your ellipse, and it's going to go through the two foci, and it's going to join the two vertices. The vertices, which we don't have labeled here, but I'm going to go ahead and draw them on, are the end points of your major axis. They lie on the actual ellipse. So this is the vertex here, this point that I just drew, and another vertex would be right here. They are on the actual ellipse, and they are the end points of your major axis. The minor axis is going to be the line that is perpendicular to your major axis, and it goes through the center. So this intersection of your major axis and your minor axis is the center of your ellipse. Okay, so now that we actually have some key terms defined for an ellipse, let's go ahead and figure out what the standard equation is. So moving on to the next slide, we've got two different equations here. One is if our major axis is a horizontal line, and the other is if our major axis is a vertical line. So these are the two standard equations of an ellipse. You have x minus h squared over a squared plus y minus k squared over b squared equals 1. That's if your major axis is a horizontal line. Or we've got x minus h squared over b squared plus y minus k squared over a squared equals 1. And the way that you know which is that b is always going to be less than a. Always. So your major axis is going to be the larger number. And so here your major axis is underneath the x, that means it's horizontal. Here it's underneath your y, and that's a vertical ellipse. Our center for the ellipse is going to be h, k. The length of the major axis is 2 times a. The length of the minor axis is 2 times b. We can find where the focal points are using some information here. So the first thing that we have to do is we have to find c. And we have this equation, c squared equals a squared minus b squared. Or we could also write it as c equals the square root of a squared minus b squared. So if we have a horizontal major axis, then the c is going to be added or subtracted to our x component of our center. If we have a vertical major axis, then c will be added and subtracted from our k coordinate of our center. Last, we have an equation for eccentricity, and this is basically tells us how round the ellipse is. Because ellipses can sometimes look like circles, but they are distinct in that they have the two focal points, whereas a circle does not. But the eccentricity tells us what that is, so how round or how oval shaped our ellipse is. Okay, so now that we have all of this information, we're going to clear that off. Let's go ahead and go into an example. All right, we need to figure out what the center, the foci, the eccentricity, and the vertices are of the following ellipse. And we are given this big, long, messy equation. So how in the heck are we going to do this? All right, we have to use algebra, and we're going to go back to completing the square. Lots of fun, right? All right, so let's first go ahead and combine like terms, because remember, we want to get this equation into the standard form. So the way that we're going to do that is combining like terms, and then we'll complete the square. So we have 9x squared minus 54x plus 4y squared plus 40y. And we're going to move the 37 over to the other side, so we have negative 37, because remember, we want our equation to eventually equal 1. Okay, so now in order to complete the square, we need to get our x squared term, and our y squared term to have coefficients of 1. So let's go ahead and factor out the coefficients. So when we factor out a 9 from our x terms, we're left with x squared minus 6x. And we're going to factor out a 4 from our y terms, so we have y squared plus 10y equals negative 37. So remember, back in your completing the square terms days, you take this middle term right here, divide it in half, and square it. So that's what we're going to do to complete the square here. So we have 9 times x squared minus 6x. 6 divided by 2 is 3, and 3 squared equals 9. So we are going to add 9 to our equation here. But remember, we can't just add 9, a random 9. We have to account for that 9, and that 9 is actually going to be 9 times this coefficient, so 81. So over here, we're going to add an 81 to the other side of the equation. That counterbalances this 81 that we are effectively adding over here. Now we're going to do the same thing with our y term. So we have plus 4 times y squared plus 10y, and then now we take this term right here, divide it in half. So we have 10 divided by 2, which is 5, square that, that gives us 25. So we have plus 25, but again, we need to account for this that's being added, and it's really 25 times 4, so that's 100, and we're going to add 100 over to this side. Okay, so now we can write our terms in the parentheses as perfect squares. So now we have 9 times x minus 3 squared plus 4 times y plus 5 squared equals, and when you add all this together, you have 144. So we want to get this looking like the standard equation of an ellipse. So we want this term right here to equal 1. So let's go ahead and divide through by 144. That way we get 1 on the other side of our equal sign. But if we divide this by 144, we have to divide both of our terms here also by 144. So when we do that, we now have the equation x minus 3 squared over 16, because that will reduce 9 in 144, and then we have plus y plus 5 squared over 36 equals 1. Now we've got the equation in the standard form. So now we can find out all of the information that we need. Okay, so now that we've got this in standard form, we can see that our major axis is going to be over here. 36 is definitely bigger than 16. And remember, this is in terms of a squared and b squared. So our a is going to equal the square root of 36, which is 6. And our b equals the square root of 16, which is 4. And that's just going to help us when we're finding out our focal points. So first, center. Let's figure out the center of this equation. So our center is h comma k, And remember, this is x minus h, so h is going to be the opposite sign of this. So this is 3, and our k is the opposite sign here, so negative 5. So our center is 3 comma negative 5. Now we need to figure out the focal points, or the foci. So in order to do that, we have to figure out what c is with regards to the equation of c squared equals a squared minus b squared. So if we plug all this in, we get c equals the square root of 36 minus 16. Oops, sorry. That's a 16, which equals the square root of 20. And this simplifies to 2 square root of 5. So this is what's going to be added to our center. And because this is a vertical major axis, because our larger number's underneath the y, we're going to add and subtract this number to our y coordinate of our center. So our foci can be written as, and we'll go ahead and write that over here, foci equals 3 comma negative 5 plus or minus 2 square root of 5. Okay, so now we're going to find the eccentricity. And remember, that's just the equation E equals C over A. So we already know what C is. It's 2 square root of 5. We know A is 6. So our eccentricity is going to be 2 square root 5 over 6, which reduces down to the square root of 5 over 3. The last thing that we need to find are the vertices. And remember, those are the endpoints of your major axes. So we know that our major axis has a length of 2a, which is 12 since a is 6. So we're just going to take this number right here and add this to our y coordinate of our center, because it's going to be on the y axis. It's a vertical line. So our vertex, or our vertices, are going to be 3 comma negative 5 plus or minus 6. But we could go ahead and simplify that to 2 different points. So we've got 3, and then negative 5 plus 6 is going to give you the point 1, and 3, and then negative 5 minus 6 is negative 11. So those are your vertices. So that is everything that it asked. We found all of the critical information that we needed to for this ellipse. Now, one thing I want to note, and we're going to actually go into this on the next slide as well, this is an ellipse because our A, which is 36, and our B, which is, or our A squared I should say, is 36, and our B squared, which is 16, are different numbers. Had these been the same numbers, so for example, if this was a 36 over here, we would have had a circle. Circles and ellipses are very similar in their equations. The only difference is that an ellipse is going to have different numbers for your denominators, whereas a circle is going to have the same number if you were to set it up in this equation. Okay, so let's move on to the next problem or example. So this is exactly what I was just talking about on the previous slide. So we have the equation of a circle. The first one is what you're familiar with, where you've got x minus h squared plus y minus k squared equals r squared, where h comma k is your center. But we could also rewrite this to where we would have it equaling 1, and that you would do just by dividing everything through by your radius squared. So if we did that, our equation of a circle looks very similar to an equation of ellipse. But remember what I said on the previous slide, your denominator is going to be the same here. So looking at our final example for today, what do we have? We've got an equation here. Is it a circle or is it an ellipse? This one's easy. It's already set up in standard form, so there's not much that we have to do here. We just take a look at our denominator, and we see that these numbers are in fact the same. So this equation represents a circle. All right, so that is it for today.